Thank you very much for coming, and people will be joining. I see people still joining. It's fine. There will be a recording. I don't know where it will be published, but I think Anna said it will be published somewhere on Tekna web page. My name is Boris. I work at ACE, one of the Aker companies. We do digital twins for oil and gas, energy generally industry. We are doing this thing for the first time, the paper talk, and I will tell my reasons behind it. But before I do so, if we do this again, I hope we do, you can suggest papers you want us to discuss, because this is more of a discussion. I'll present, of course, everything I understood and read in the paper. The paper is quite dense. Dense with social science terms, which may not be necessarily very comfortable for some computer science people. It was hard for me I had to Google a lot, which is completely normal when you do research. You have to Google a lot of terms. You can't know everything, but I find it an interesting exercise to dive into a paper and sort of understand the details, but also a general overview, how it's structured, what people are talking about, what do they reference, how do they reference. So this talk is should be useful both for professionals, but also researchers. Because again, as I said, we're going to be analyzing a paper, and it has a lot of practical uses of certain frameworks, certain ideas that can be implemented in your workplace. My background, I am a computer scientist by training, but I've gone into AI, and I've been working with natural language processing analysis for the past 6 probably years now. So I started pre-transformer time using LSTMs and LTK libraries, and now moving more into the generative pre-trained models. What else? Let's see, what did I write? So I'm at home. My setup is I have laptop and I have the screen in front of me, which one the presentation that you see, I see slightly higher up, just for reference. The presentation doesn't have notes. My presentation, a copy of this presentation that I have on my laptop has notes. I would have to be switching, and I hope I'll keep it sync. Again, this is the first time, so I didn't really know how to do it the best way. But hopefully you can stick with me. And the little disclaimer is that I had to eventually use LLMs making presentation, because I initially collected all the own thoughts and thoughts from the paper into a lot of text, a lot of writing on the side, and then I had to structure it. And structuring usually takes a lot of time, so I used LLMs to sort of help me with structure that is in the presentation. When I was going through the presentation today and yesterday, I noticed that some things are not the best way I would structure it, but I hope, and there's some repetitiveness in it, but I hope the presentation will be understandable. And another thing is you would see that there are some repetitiveness in the presentation, but so is in the paper. So this is not unusual, because the ideas sort of recycled through the paper, and they're reused in slightly different context, maybe later in the paper talking about slightly different topic, whereas similar ideas from previous chapters still apply. And I opened Tekna page for the talk, and I see that the description is slightly outdated because the description was written before me making the presentation. So the first point is overview over standards like NIST, AIRMF, and the EU AI Act. There are some mentions in the paper, but they aren't central. The ideas, how to practically implement those ideas from those standards are mentioned, but we are not going to be going into details about the um, the ethical frameworks that are nationwide or countrywide. Okay, so I think that is about it. So we can go into the paper, and there is a QR code. You can follow the slides with me, and you can save a copy. At some point, I guess I'll delete the slides because they're stored in my local drive. So I suggest if you want to keep them, download them. So let's first talk about Tekna's nationwide professional networks. So there, I don't remember how many I can count, 13, 14, but there are different networks and they focus on different topics. You can be part of multiple of those networks, and each of those networks, they make events or create events that promote the topic that these networks are structured around. So big data promotes topics about big data, AI, machine learning, data science, but things like Jernbane, which is God, what's the English word? Trains and railroads. They focus more on railroad related items. So are the other networks. What value we bring to members is, first of all, it's a professional network to grow your to do networking and grow your connections, make new contacts, and you by doing so you can create or get more partners and get brainstorming ideas and making talks like this where you can actually express your thoughts and express your opinions and make people aware of things that you work on, for example. And yeah, we try to make people stay on top of their subject through our network, at least in big data, by doing talks like these. So we can jump directly into the paper. This is the first couple of slides are going to be an overall picture before we dive into individual chapters. 2024 was exciting, and this is why I wanted to squeeze in this presentation before the year end, because there was a lot of controversy about LLMs, and you've seen it all around internet, news outlets, LinkedIn, etc. Here are some taglines or clickbaits by some of the news providers, research portals, etc. And you can see that, well, LLMs are a trend. GPT is a trend these days, still is. There are a lot of other models that do similar things. They interact with the users of those models, and you can use them for good things and sometimes specifically bad things. And sometimes this line isn't very well defined. There's a lot of gray area in between. And today we'll try to, through the framework of ethics, we'll try to look at this gray line and see what you should be thinking about when doing research or adopting LLMs in your work. So first of all, the data. Of course, we'll be talking a lot about the data, and I found this from KD Nuggets that in order to train GPT-4, which is, I believe, the latest version of the GPT-4o, it was used 13 trillion tokens, which is about 10 trillion words. And it's hard to imagine what that actually means. It's a big number. And then, okay, so what is, if we think that 10 trillion words, how many average books there are? So I've tried Googling and see how many words per book there usually are on average. It's about 90,000 words per book in a novel. So that would be, let's see, so it's about what's this number? It's 1 billion Am I reading this right? 1 billion average books? Yeah, I think so. 111. No, 111 millions, right? 111 million books. And then, okay, so how many books person reads per lifetime? Google said it's about 770 books. So how many people would it take to read so many books through their lifetimes? About 144,000 people reading books continuously as a normal human would be doing throughout their lives. That's how much information there is embedded or captured in the current GPT model. And then I was trying to find what's the average Norwegian city. So in Stavanger, we have a population of 148,000. So it's Stavanger people reading books throughout their whole life. That's how much information there is embedded in the GPT-4 model. That's insane. I think it's insane. It, and when you think, okay, if it's so much information, how do we make sure that this information is non-biased, that it's ethical, that it's inclusive? One person cannot go through all this information to find that. So we have to employ some kind of algorithms to analyze the data before we use it for model training. And then how do you design those algorithms? Because if you employ some metrics, how do you make sure that those metrics for analyzing your data are inclusive, they're ethical, they're non-biased? So this is what this talk is all about, is looking at those topics. So we can start with asking a first question. Why do we need ethics in AI? And this talk is about LLMs, but it's also very applicable to general AI topic. So here it says, AI is deeply integrated in the daily life, shaping our experiences, some of which can be harmful and hard to address. And a simple example that you've probably seen in the news as well is that a lot of these AI algorithms, they're used in hiring, in lending money in banks, in law enforcement as well. So how do we make sure that people who are affected by this technology, um, they're not being discriminated against? And I think it's very important, since, as it says in the statement here, is that we are affected by all of this technology every single day, whether we want it or not. Now, key ethical challenges in LLMs, they are social consequences that are unintended. You can think of it as an example, for example, facial recognition. I think, I tried finding online, and it said that about 1% of white male during facial recognition, about 1% is there is about 1% error in facial recognition for white men, for example. But if you look at Black women, it's about 34% failure. So you can see that there is already a huge discrepancy in the facial recognition systems, which have been for many, many, many years already, and they're used in different settings in different industries. Then we have language bias. So for example, if a model manages to associate male with engineering degree and the female with healthcare, then those biases will be captured by the model, and they'll be perpetuated further when this model be used in different scenarios. For example, again, in money lending in banks, in law enforcement. So language bias when encoding and storing the data and then using it for training can also amplify model fairness in the future. Then there is, again, whiteness issue. It's for example, a lot of data that's used for training those language models, it's usually very biased towards whiteness. So it's only recently, so when I was looking for a postdoc myself a few years back, I was talking to Singapore University where the main topic was collecting data for Southeast Asian languages, for example. So although this type of research has been already performed for many years in the US, for example. Then there's a benchmark bias. It's the benchmarks that are published, they are usually biased against minorities. It's basically the same thing here that the dialect misinterpretations in the language models and the biases are embedded in the training data as well as in the validation test data, unfortunately. So safeguarding user privacy remains still a big challenge because of sheer size of the data that is used for training language models. It's simply impossible to manually go and remove privacy information from it. And then another problem is that when you collect the data from different sources and you aggregate it, there can be links made between the data, which may actually expose a person, although initially in different resources, this data was anonymized. The hallucination is the is a big problem because the models sometimes are very confident about their responses, but when they this data is used, you can see right away that the data has been fabricated. It's just a nonsense. I think the recent one that I've seen is how to make cheese stick to pizza and make it more cheesy. The language model responded, you should add glue to that. Because somebody somewhere on forum joked about doing so, but the model didn't understand it was a joke. And there's a copyright infringements. So how to protect intellectual property rights when using the data for training. So this paper offers some actionable best practices for researchers and practitioners to uphold ethical standards, LLM research and development and deployment. Let's go, try to go a little faster. So, anticipating ethical considerations. So first of all, there are frameworks and tools how to do this. The basic questions you should be asking in the beginning is why should you have a AI or a smart solution for the problem that you're facing? And then the next question after that comes right away is that how the solution can be abused if you use some smart methods, some black box solution, how to make sure that the people using it are not going to abuse it in some way. Then there is a assessment list for trustworthy AI. It's developed by European Commission of high-level expert groups on AI, and it provides a structured approach to evaluate and ensure that AI systems are developed and deployed in a manner that aligns with ethical principles and legal norms. Then you can perform auditing either during development. So the whole paper sort of encourages people to do all of these ethical considerations before deployment, because once you deploy, people might already start abusing your system. So you have to start asking questions before or during the development. So you can perform algorithmic audits where you use metrics for demographic parity, equalized odds, or disparate impact. So those things basically mean there are formulas, mathematical formulas describing this, and they analyze your data and try to provide information about how many outcomes there are in your data that covers different demographic groups. So you have to make sure that you also perhaps have batches of your data before training where you balance the data as much as possible that represents all demographics in it. Then there are audits to ensure compliance with company policies, industry standards, and regulations, of course. So risk assessment and anticipation. And the obvious one is reading about likely risks, and there are papers providing sort of point by point things you should be thinking. What are the risks, potential risks of your models or your solutions being abused? And there's AHA, anticipatory harms of AI, which is also it's a tool for harm anticipation that proactively allows you proactively identifying and mitigating potential harms or risks associated with the AI technologies. And there are guidelines for development. There are design principles for generative AI applications, and collaboration frameworks that explicitly tell how do you include shareholders in the development of your models and data collection as well. So this here is specifically focusing on stakeholder inclusion. Here we have, if I would summarize all of this, I would say that you have to always make sure you include people that you collect the data about, because their opinion about their own data matters, and they are the ones that can tell you how the data was supposed to be used, if they write something on the forum, it's only them who know the context that they've written it, because it says somewhere in the paper that when you think about something and then you write it, you already do some kind of transformation. So what you write may already not represent what you actually thought about. So including those people in your studies or your data collection or your implementation design stages is extremely important. And there are tools and frameworks for identifying taxonomies of stakeholders that where you can address imbalances and ensure that the stakeholders' power dynamics don't necessarily tilt your perception of the data one way or the other. So it's as balanced as it could be. Then, of course, we have environment and sustainability. The slide is pretty self-explanatory, so you have to make sure that you are not abusing energy, which is a very big factor these days. There's a lot of misinformation online also about how much energy the language models are using, and that they're not sustainable, that they're bad for the environment. There are actually frameworks where in Python, for example, you can simply do pip install. There are libraries that allow you to measure carbon footprint when you're doing fine tuning or when you're using the model in production, which is actually very useful to see how much energy you're using for your AI solutions. And there are general guidelines and best practices about using sparse architecture over dense ones, because sparse architecture use less energy, because there are less activations of nodes inside your LLM, for example, using cloud computing that relies on renewable energy, and performing optimization of your solutions by doing pruning or distillation. But you have to keep in mind that when you do these things, it can affect the fairness, because you simply tell the model to, well, it's hard to translate it directly into the result, but you are pruning the details that the model might remember about certain things. It will come up in slides later on as well, how distillation and pruning can affect fairness. So, spend half an hour today's topics. We'll basically go into details on all of these things that I already mentioned. So it's data collection and sharing, data cleaning and labeling, the development of the model, performance and harms evaluation, and the deployment. So the first one is data collection and sharing. Here the paper talks about before you even start collecting your data, you have to think about your personal biases and your positionality. Your things are like cultural background, social identity, your socioeconomic status means a lot, your professional background, your ethical values. You don't necessarily have to document all of these things, but there are some suggestions in research actually that you actually should be maybe on a higher level, but not necessarily in detail, because people using your data afterwards, they need to make sure they know how to use it, and having this information available will allow them to, for example, write more accurate what's called reproducibility documents, whether your model are should be used in certain scenarios, for example, in talking about indigenous people or certain races, certain genders. So at least you should start there. You should analyze your own biases. Another thing which I already mentioned is that the data that is created and then repurposed, very often what's seen by researchers that when the data is repurposed, it will, or very often it's repurposed in different contexts. If the data was made for a specific task, it might be used in a different task, which means it's already not suitable or less so suitable, and you have to make sure that you understand the data collection that you used in your own work, what it has actually been collected for, and then make judgments on whether it's appropriate to use it in your research or not. Then there are common web crawling, collecting data online, because as we started this talk, is there's so much data that's used for training these models. You simply have to scan the internet and get as much data from it as possible. But then the problem, there is an ethical problem. When you copy the data from online resource and use it in LLM, first of all, you're copying the data, and second of all, you're repurposing it, and then this data is going to be used for some other application. So if you compare it, for example, with Google search, what Google does instead, it does indexing of the web page. It uses files like robots, text file on your website, and then it so first of all, when you put the robots text file on your website, you have to think, do you allow your data to be indexed? So then it's user responsibility or the data producer responsibility to think about this. And when Google indexes it, it doesn't copy, it simply makes an index that there's a URL with this kind of information, and then it forwards the whoever uses google.com or Google website onto that website. So there's no copying involved. So there are some ethical concerns about this, whether when you copy and when you index the data. And then you have to think that when you scrape the data, it contains a lot of sensitive information, and it also overrepresents certain groups. So because most of the data online is from English speakers or English users, English language users, and yeah, and so you have to keep that in mind, that the data is overrepresented in certain demographics. Consent and safety issues. So something to keep in mind is that copyright, it protects data producers. So you can write a copyright on the data that you produce, but then the privacy laws, they're different in different jurisdictions. So, for example, Europe is very influenced by the GDPR. US does not have a centralized body for copyright privacy laws, and China have their own rules. And it's not necessarily true that the points within those laws will match from jurisdiction to jurisdiction. And then another point, I think it will come somewhere else, somewhere further in the presentation, that those can change over time. The copyright can change over time. And then you, as a user of the data that you collected, you have to make sure that you go back and you check from time to time what's the current copyright on that data. And their usual, what people already know probably is that a lot of people don't know that their data is being used for LLM training. As I mentioned previously, cultural competence is crucial or critical when you're when using marginalized groups' data. If you use data from indigenous people, for example, in your data sets, you have to know the culture at least a little bit. You have to understand what is written, what kind of slang perhaps, or what kind of dialects are being used, and what those mean. Because sometimes the slang or the dialect can either be written in a different form, or it can mean a different thing if you read it from a perspective of a person from a marginalized group. Data sharing, de-anonymization. So the thing that I already mentioned is that when you do aggregation of the data, when you collect it from different sources and you put it all together, and then you let your model or analyze the data that you collected, it can start making patterns that weren't possible if you would train on either one or the other resource. So this is data aggregation. Within the data aggregation, what happens sometimes is that you can start identifying individuals within the data when you do aggregation, and this is a privacy concern. They are things like indigenous data sovereignty. It advocates for marginalized communities' control over their data, which means that if you include their data, or data from these communities in your data sources, you have to understand the culture, you have to understand the language and what the context that data has been written. We can move on to responsibility data sharing. So there is one methodology that is quite sort of prevalent these days. It's called data sheets. When you're collecting the data, you have to make sure that the data sheets, they represent as much information as possible about the collection of the data. Its uses, what's composed of, very basic stuff, which resources are used and their intended uses, and also its limitations. And there are platforms like What's in My Big Data that identify issues in text comport that's already published and that's used for either validation or training. And as I mentioned previously, the terms of service can change, affecting data usage. So this is something to keep in mind and come back and look at those terms of service. Data cleaning and labeling. So here we are going to be talking about when you collect the data, you have to clean it before you start labeling. So which starts with removing irrelevant languages, removing offensive content, and removing private information, whether you do it automatically or manually. And as I said previously, when you have huge data sets, it's very, very hard to make sure that all of this is filtered the way it was supposed to. The filtering itself can introduce biases. So one example that I was thinking when I was writing this was Kurdish language. It's quite suppressed in Turkey because of the political situation, and it's prohibited to use the language in the country. So the question is then, when you have a data set and you have a little bit of Kurdish in it, does that mean that this language should be filtered, it should be left? Or should you balance your data set to include this equal amount of Kurdish versus Turkish? And another point here is balancing data instead of over filtering to reduce the bias. This is exactly what I mean by making sure that you have representation from all communities, from all the demographics in your data. And then it's suggested that you should view data harm as a spectrum rather than just, is it harmful or is it not harmful? Because the dirtiness of the data is quite a subjective matter. So you should think, you should decide when you're writing the data sheets, for example, you should decide, or you should be explicit in the data sheets that you think so and so, that I draw a line here that this data is dirty, this data is clean. Because this can lead to different levels of harm when you are using the data that is labeled wrongly, or not ethically, in training of your models. You have to make sure that when you do labeling that you simplify the reality, unfortunately, because we have to discretize our data. And you have to, when you do so, you have to make sure that you document all of this in the data sheets, that you draw the line at certain places in your data. The annotation biases, again, as I said previously, you have to make theories of gender explicit in your data sheets. You have to explain that you consider gender, for example, to include man, woman, and non-binary categories, and not something else or something more or something less than that. You have to collaborate with affected communities for the cultural sensitivity. That's what I meant when I was talking about that you have to get the perspective of those communities when you include their data, because you as a person with your own biases, with your own background, may simply misinterpret the data. And then consider the risks of releasing low quality data for evaluation. This will come later down in the presentation. This is very, very important. First of all, it can lead to false confidence in your data. And when you release the model, the users of that model will eventually find, oh, this model is very biased towards certain demographics. Yeah, so we'll come back to this later again. Hopefully time permits. The annotator impact and rights. So there are obvious annotation biases. Your education, gender, culture as a labeler matters a lot because it affects your content interpretation. And then another thing is when you're outsourcing the annotation, for example, to platforms like Amazon Turk, or other resources, you have to make sure that you understand the implications of outsourcing your data, because there's a different, or research has suggested that the quality of data annotated from these platforms, it varies. And it has been suggested to use psychometric tools. So things like personality tests, the big five, or the IQ test, or all of them actually, IQ test, emotional intelligence tests, to provide the data about the annotator, because then you will know what led the annotator to make those labels in your data. You have to handle disagreements, and this is a very common thing, even if you don't go into this rabbit hole of ethics. When you simply have more than one annotator, you sometimes have to handle the disagreement between the annotators. And there are two ways of doing so. Either you do metadata for handling disagreement, and the idea behind the metadata is that the same gender, for example, will have similar metadata. It aims to capture clear signals from groups by encoding annotator metadata. So the group of annotators should have similar annotations. Or you can go the distributional method, which means that you allow flexibility in annotation, but usually limited to only two options to make sure that it's not the whole world of annotation is possible. You have to consider the rights of crowd workers when you, for example, outsource annotation to the Amazon Turk. They have extremely low wages. There are no security in their work conditions and their lack of rights. So this can have effects on the annotation. And when you seek approval for annotation, for outsourcing the annotation for certain applications, you must seek ethical approval, or you should, because you have to think in advance which platforms you will use and how you will treat those annotations. So we go to model development. First thing to think is that when you train a model on a biased data, it usually amplifies the bias in that data through the model, unfortunately. And when we're training our models, we obviously go through stages. We go through tokenization, we go through encoding, and the bias can surface in all of these stages and can be amplified even further. So, for example, in tokenization, with tokenizers, it usually breaks down words into segments or words or a couple of words. And it uses, as far as I'm aware, it uses English language as a reference. So, for example, with languages like Thai, Thai does not have words. Everything is just one line. It doesn't split into sentences, it doesn't split into words. So how do you then perform tokenization? You would have to perform it at a superficial level, unfortunately. And then also talking about the different languages is when you do tokenization, how do you make sure that the same tokens are used for different gender terms? Unfortunately, the research shows that the tokenization done for different genders in different languages across the same language even can sometimes lead to different tokenization, which is obviously a problem because we don't want to amplify gender biases within the data. Then its encoding methods impact non-standard dialects. As I mentioned previously, is in dialects you can have same words have different meanings because of simply dialects, the slang, etc. And how we make sure that when we do this kind of encoding, that we do it uniformly across dialects, slangs, etc. Even simple things like learning rate can have effect on marginalized identities, because if you have too high learning rate, you can simply bypass the global optima. You can end on the local optima, which will have a bias towards a certain demographic in your data or in your model. It has been shown that larger models, they generate toxic responses, more likely to generate toxic responses with toxic prompts. But they're also much more accurate classifying toxicity. And they also have, larger models have higher capacity to avoid harms when instructed to do so, which means they just simply have more capacity to learn nuances in the data. which is both a good thing, but can also be a bad thing. And then, as I mentioned previously, pruning distillation may worsen the performance on underrepresented features because you simply cut off that kind of detailed information that the model has learned when not before performing any pruning and distillation. It has also been shown that some compression techniques, they actually reduce toxicity by forgetting this harmful content. So as you see, again, it's a balance, whether you do want to remove the harmful content by performing distillation, but then you can also lose underrepresentation in your model and your data. The techniques for fairness and debiasing, we have fine-tuning, which can reduce harm and bias. You have reinforcement learning with human feedback, where you learn the fitness function or optimization function through human feedback. It can help reduce bias, but it has also limitations that by doing so, you can introduce new biases, and effectiveness can be limited or infeasible, where, for example, if you're using ChatGPT and you're trying to construct a prompt to exclude harmful content, it can have very limited effect. Either you have to be very careful designing the prompts, but even then there is room for the model for this harm to surface. Then we have expectations. This is a little bit of a controversial topic. Is you obviously have different objectives with your model, with your solution, and those trade-offs, they usually sway from adhering to human preferences and societal norms to upholding some kind of a ethical principle. So those are sometimes contradictory. They're contradictory across cultures as well. So if you have your model designed for a specific target group, you have to make sure that when you perform this alignment, first of all, it's documented in your data sheets, and that your model is tested appropriately before you do the releases. Then there are model cards. So this is, people are becoming more and more aware of this these days. It's where you document the benchmarks that were used for evaluation of your models across different groups, diverse groups and diverse contexts, and disclose performance characteristics and intended use context. So you have to provide information about how evaluation has been done and what context the model should be used in. We have 9 minutes left, so let's try to go faster. Ethical performance evaluation. So when you have developed your model already, then you have to evaluate it using your validation set or test set. And then you have to think about what bias is present in your test set. Because again, as I said previously, is that if you are using bad validation set with a lot of bias, it might give you a wrong impression of your trained model, and it will be released, and the users will eventually find that your model is actually extremely biased. There are metrics for performing tests on the trained models. Those also have limitations in themselves, like you have Rouge, Rogue, you have Blue, you have Bird Score, and they tend to only look at n-grams of the text that is being generated. Unsurprisingly, they tend to prefer machine-generated texts, and it's extremely difficult to embed things like fairness of inclusion in these metrics, just as simply as that. You have then benchmarks. So you have glue, you have MLU, um, and you have to remember that when you're using these benchmarks, that they are task specific. Their context is fixed, which means if you're trying to test your model on whether it's inclusive, you wouldn't be able to do so because it's simply not part of those benchmarks. It's not included in them. Yeah, that's unfortunate. And the bias in those benchmarks, the underrepresentation of demographics on demographics can skew your results, and you can become again overconfident in your model's performance. Whereas when you release it, users find out that it's actually biased. And as like Krog, I don't know how you pronounce the name, says that some things like ethicality cannot be simply measured by those benchmarks alone. You need to have, unfortunately, human feedback to be able to assess that. There are solutions for better evaluations. You can get some inspiration from software engineering evaluation, so you can do behavioral and black box testing, focus on input-output behavior beyond just simple accuracy of them. You can have audits, as we mentioned previously. You can do somewhat automated measurement by you looking at the data distribution. And you can do adversarial testing where you actually have either a user or an expert, specifically user, to try and trick model into providing a response that is biased. And by doing so, you can evaluate your model's biases. Then there are harms evaluations. The lack of rigor is something to keep in mind always. May harm evaluation. Wait. Oh, right. Many harm evaluations lack methodological consistency. It's a semi-new area of research and is being surfaced more and more right now with the popularity of LLMs. But unfortunately, the terminology, the methods that are used, there's a lot of work to be done there. So if you're looking for area of research, this is a very current and also under researched area. Then when you're doing harms evaluation, you can assess on harm areas where the model is hallucinating and sort of representing imposter effect, where it gives you very harmful suggestions like putting glue in your cheese for it to stick to pizza. Then there's, as I mentioned, lack of terminological clarity and methodological precision, and unfairness and bias testing. It needs better definitions with collaboration with people from these fields, usually social sciences, and expanding in more non-US, non-English contexts when collecting benchmarks is also something very useful to do. Because we don't have much time, I'm going to skip this and I'm going to go further into deployment. This is the last topic. So when you're deploying your model, a very simple checklist is you have to think of consider your consideration during deployments that there's potential bias, stereotypes, and representational issues in your model. It can potentially violate privacy. There can be data misuse. The environmental impact that you're making onto by deploying your model. The financial costs and moderation labor, so how user provide the feedback, how do you manage costs associated with deployment and production ready models. And then something to think about is that the trust can erode over the time if you have a very biased model out there and people are using it. Both trust in your model, but also in the whole field. There's dual use concerns. They're very prevalent these days. The model can be used to generate content that appears neutral, but subtly it sways readers towards a certain political beliefs, for example, often through biased framing or selective presentation of facts. There are mitigation strategies explored. So you can do watermarking, you can identify AI-generated content and market out there. You can share risk cards where you do risk assessment for new models and people contribute to those. You can do licensing terms. You can restrict the model completely from using in a specific context because it can potentially harm people to use the model there. And you can do partial releases over time. First gradual, you can monitor, get feedback, etc. Yeah, so let's move further. We have 1 minute left. Let me jam this whole thing because this is the last slide, basically. When we say that the model is open, what does it actually mean? Does it mean that the weights are open, that the training data is open, that the model can be downloaded and reused in any context? So some openness criteria is sometimes not properly documented. Performing stage releases, you do first trusted researchers release, then pre-release audits, and then post-deployment monitoring with the feedback. So this is extremely important, the ripple effect. This is what I already mentioned in the previous slides, that data coiling as well, it's called. When you release a bias model out there and it generates content that is published on the internet that is biased, and then the new researcher comes in and they pick up this generated bias data and they use it for their own model training, the model enhances that bias even more. So it's a sort of perpetual bias echo chamber that unfortunately can end up being as a part of the whole internet, really. So it's something to keep in mind. You can put guardrails onto your model. So you can do, of course, output filtering and prompt modification if you are able to do so. And you can add warning labels for sensitive outputs, but it has been shown that it's a controversial topic, and even marginalized group think that it's not always a good idea to put warning labels on generated data. Anna, how are we? Because it's 12 o'clock and the last topic is for using LLMs in education. I guess I can quickly mention that there has been good indications to do personalized education, but in order to do so, first it's the digital literacy that's important to have, and then both the institutions that do serve education and the educators and the people being educated, they all have to know about the limitations and potential biases that can be introduced with these models. And this is not always the case because it's still partially in its infancy, and people need to be educated more about how these models can be misused and what consequences it can have. And then if you are a researcher or a practitioner in this area, make sure that you provide accurate information about how these models can be abused. And also when you are designing models, make sure that you have documentation as clearly as possible so that the future people that pick it up can know about the model's limitation. Don't contribute to the hype that's already out of control, I think. So it's very important that we all agree that it's important to sort of be mindful of potential harms LLMs can bring. That's it. I think that is it. There are TLDR that you can look at yourself. There are references that are in the paper. So it's just look inside there. And questions and answers.